Today we are doing lesson 16.1 and 16.2, exponents and products of powers. Our I can statements for today: I can write expressions using integer exponents. I can evaluate expressions involving integer exponents. I can multiply powers with the same base. I can find a power of a power, and I can find a power of a product. All right, so let's take a look at our first type of problem. So the first type of problem, they ask us to write each product using exponents. And this is actually a review of something that we've done at the very beginning of the year. Exponent tells us how many times the base is multiplied by itself. So for example, on this first one, we have -7 times -7 times -7. If I'm going to write that using exponents, I'm going to write -7. I'm going to keep it in parentheses because the negative is part of my base. And then I'm going to write to the third power. And the 3 is from the 1, 2, 3 times that -7 was getting multiplied. The parentheses are very important. If I didn't have the parentheses there and I wrote -7 to the third power, that would mean that would mean 7 to the third power, and then take that answer and make it negative. So parentheses with the negatives and the exponents, it is very important. All right, let's take a look at B. This time, instead of numbers, I have symbols. I have pi times r times r times r. So I have 2 pi's, so I'm going to write pi squared. And then I have 3 r's, so I'm going to write r cubed. And when I write them right next to each other like that, that shows that this value and this value are multiplied together. So pi squared r cubed means the same thing as this. Okay, go ahead and pause the video. Take a minute to try these on your own. Okay, let's check our answers. So here I have 1, 2, 3, 4, 5, 1/4. So I'm going to write 1/4 to the 5th power. And usually with fractions, you see that parentheses around there to indicate, make it clear that 1/4 is the base. It's not 1 to the 5th power divided by 4. It's 1/4 to the 5th power. All right, let's see. 1, 2, 3, 4 of the 3/10. So 3/10 to the 4th power times 1 to x squared. All right, let's take a look at our next type of problem. Evaluate each expression means to solve it and find an answer for it. All right, so -2 to the 4th power, -2 to the 4th power. This is what I was mentioning before. Parentheses are very important with exponents. It makes a difference in what we do. So here we have -2 to the 4th power, and because -2 is in the parentheses, that's what's getting multiplied every time. -2 times -2 times -2 times -2. All right, so let's see. -2 times -2 is +4. -2 times -2 is +4. 4 times 4 is 16. We are evaluating here without a calculator. Okay, B looks the same, but it's actually not. It's -2 to the 4th power. What that means is negative value of 2 to the 4th power. Okay, well, 2 times 2 times 2 times 2 is 16. I just figured that out up here, so I won't write all that work. And then I've got the negative in the front. So for my first one, that had a value of a +16. My second one had a value of -16. All right, let's take a look at our next one. So evaluate each expression. Again, in our lesson today, we are not using calculators. Okay, so we are doing order of operations. Order of operations, first step is parentheses. I don't have parentheses. Our next step is exponents, 3 to the 4th power. Okay, so I'm going to do that over here. 3 times 3 times 3 times 3. 3 times 3 is 9. This is also 9. This is 81. Okay, so we have 3 plus 2 times 81. Okay, 2 times 81 you might be able to do in your head. I'm going to show the work though. 1 times 2 is 2. 2 times 8 is 16. So I have 162 plus 3 is going to give us 165. All right, let's take a look at our next one. 3 cubed minus 8 squared divided by 2. Okay. 3 cubed. 3 times 3 times 3. 3 times 3 is 9. Times our next 3 is going to give us 27. So 27 minus 8 squared. 8 times 8 is 64. Divided by 2. Then we do division. 64 divided by 2 is 32. Then we're doing subtraction. We're taking away more than what we have, so we're going to do a boom boom here. We're going to make that 27 plus negative 32. Different signs, find the difference. I'm going to go ahead and write it off to the side just to show my work. 2 minus 7 takes me into the negative, so I borrow. 12 minus 7 is 5. 2 minus 2 is 0. I have more negatives, so my answer is going to be a negative 5. This is the type of work I'm expecting to see for this type of problem. All right, go ahead and pause the video and try these next 4 problems on your own. All right, let's double check our answer. Negative 5 to the 4th power, there are no parentheses, so that means the negative value of 5 to the 4th power. All right. This 5 times 5 is 25. This time 5 times 5 is 25. We're going to need to multiply and make our final answer negative. All right, 5 times 5 is 25. So write the 5, carry the 2. 5 times 2 is 10, plus 2 is 12. Okay, cross this out, add a placeholder, 0. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. Okay, 5 plus 0 is 5. 2 plus 0 is 2. 1 plus 5 is 6. And I know I need to make my answer negative, so it's going to be a negative 625. All right, let's take a look at number 4. Negative 1/6 to the 3rd power. So that's going to be negative 1/6 times negative 1/6 times negative 1/6. Okay, negative 1/6 times negative 1/6, same sign, answer is positive, so positive 1 over 36. Okay, times, now I have a negative 1/6. Different signs, answer is negative, so negative 1 over, and then down here, I'm just going to do my 36 times 6. 6 times 6 is 36. 6 times 3 is 18. Plus 3 is going to give me 21. So I have negative 1 over 216. Okay, let's take a look at this next one. These are absolute value bars. It's been a long time since we've seen those. Absolute value means the distance from 0, so we're going to calculate our answer, and we are going to make our final answer positive. Okay, negative 3 to the 3rd power divided by 27. Now, absolute value symbols act like parentheses. You have to do whatever is inside of them before applying the absolute value and then calculating the rest of the problem. So we're going to start with negative 3 to the 3rd power. I'm going to do my work down here, I think. Okay, negative 3 to the 3rd power means 3 to the 3rd power and make it negative. 3 times 3 is 9. Times a negative 3 is going to be 27. Negative, negative. Okay, so now I have the absolute value of negative 27 divided by 27. All right, negative 27 divided by negative 27. Different signs, answers negative for multiplication and division. But then I have the absolute value of negative 1, which is a positive 1. All right, and then let's take a look at our next one. So order of operations, we do exponents, then multiplication, then subtraction. So I'm going to start with this 2 to the 5th power. I'm going to do that work down here. I need 5 2's in my multiplication. These 2, that's going to be a 4. These 2 are going to be a 4. And I have another extra times 2 at the end. 4 times 4 is 16. Times 2 is going to be 32, so that's 2 to the 5th power. 9 minus 32 times 5/10. I know 5/10 is like 1/2. 32 divided by 2 is going to be 16. However, for those of you that have, it's been a while since we multiplied by decimals, and if you have something like 2/10, 3/10 that you can't easily do it in your head, I'm just going to show you that work over here. We multiply like 32 times 5, and then we put 1 decimal in our answer because we have 1 decimal in our problem. 5 times 2 is 10. 5 times 3 is 15 plus 1 is 16. 1 decimal in the problem, 1 decimal in the answer. So that's where I got my 16 from. Okay, 9 minus 16. I'm taking away more than what I started with, so I'm going to do boom, boom. All right, different signs, find the difference. So I'm doing 16 minus 9. All right, so 16 minus 9 is going to be 7. And I have more negatives, so my answer is going to be -7. All right, let's take a look at our next one. In sphering, a person is secured inside a small hollow sphere that is surrounded by a larger sphere. The space between the spheres is inflated with air. What is the volume of the inflated space? And here it says, note the volume of a sphere is volume equals 4/3 pi r cubed. Now, when we did anything with pi, we did use a calculator, so we'll use a calculator to help us out on this problem. Okay, so let's take a look at this one here. We have a big sphere, we have a small sphere, and then we are looking for the volume in between those. So we're going to find the volume of both spheres, and then we're going to subtract them to get our answer. Okay, so radius cubed, I'm going to do 4/3 times pi. I'm going to leave it as a symbol for right now, and I'll show you why in just a minute. Radius cubed, our diameter was 3, so our radius here is going to be 1.5, because radius is only halfway. Okay, so we're going to do 1.5 3 times 1.5 times 1.5 times 1.5. Oops, not 15, that's 1.5. Okay, so for the big sphere, let's see, I'm going to do 4 divided by 3 times pi. And actually, I take that back since I've got thirds and I've got decimals. I'm going to go ahead and make that 3.14 as I'm multiplying it out. Whoa, didn't mean to do that. Just going to erase this. 4/3 times 3.14. All right. There we go. Okay, so now I'm going to go ahead and multiply. So I'm doing 4 divided by 3 for the 4/3 times 3.14 times 1.5 times 1.5 times 1.5. And I get 14 13/100. Okay, now I'm going to do the same thing for my small sphere. The diameter is 2, so the radius for that one is going to be 1. So 4/3 times 3.14 times 1 times 1 times 1. Okay, so let's go ahead and calculate that out. 4 divided by 3 times 3.14, and then times 1 times 1 times 1 is not going to change the value. So let's see, I have 4.186, and the 6 is repeating, and so on. Okay, so now to get my answer, I'm going to need to subtract my values. Now I have a repeating decimal here, so I think I'm just going to round to the nearest hundredth. I know my answer is going to be a little bit different than the exact answer, but I knew that already because I've got 3.14. Let's see, does it tell me how to round my final answer? No, it does not. Okay, so I'm going to call this 4 and 19 hundredths. So 14 and 13 hundredths minus 4 and 19 hundredths. And when I do that, let's see what I get. 14 and 13 hundredths minus 4 and 19 hundredths. And that gives me 9 and 94 hundredths. So approximately 9 and 94 hundredths. And then I do need a label. Looks like we're dealing with meters, and volume is always in cubic units, so it's going to be meters cubed. All right, so all of that was our first part, which is 16.1. Now we're going to move over into 16.2, which is product of powers. All right. So for our key idea for this part of our lesson, product of powers property. It says to multiply powers with the same base, add their exponents. So if I had 4 squared, it's like 2 fours, and then 4 cubed, 3 more 4s. I can do 2 plus 3, and I know that it's like 4 to the 5th power. I have 5 4s to multiply. To find a power of a power, multiply the exponents. So if I'm doing 4 to the 6th power to the 3rd power, that means I have 3 groups of 6s. And I could find out how many, what my exponent's going to be by multiplying those together. So I had 6 4s and another 6 4s and another 6 4s. So that's like doing 6 times 3, which is 18. I would have 18 4s to multiply. And then power of a product property. To find a power of a product, find a power of each factor and multiply. So for these first two, in order to do this, it has to have the same base. In order to do that. But on this one here, we have different numbers, and you're just basically doing like distributive property. So 3 times 2 to the 5th power is the same thing as 3 to the 5th power times 2 to the 5th power. We took that 5, and we put it on each one of those numbers. All right, so let's go ahead and try some of those problems. Okay, first one, 2 to the 4th power times 2 to the 5th power. All right, so for this first one, I'm just going to write it out to kind of show you where our answers are coming from. 2 to the 4th power means this, 2 4 times 2 times 2 times 2 times 2 times 2 to the 5th power, 2 times 2 times 2 times 2 times 2. Do I have 5? 1, 2, 3, 4, 5. Yes, I do. Okay, so how many do I have altogether? Well, I have 2 to the 9th power. Now, I'm not expecting you to write all of that out. A way to show your work would do something like this. 2, and then we're adding 4 plus 5. I just wrote it out so you could kind of see why that works. When I have the same base and I'm multiplying them together, I can add the exponents to find out how many I have. All right, let's see. -5 times -5 to the 6th power. Well, -5 by itself is like this. -5 to the 1st power. I only have one of them. So now I'm going to add those together. -5, and I'm going to do 1 plus 6. That's going to give me -5 to the 7th power. Those parentheses, very important. Make sure it's there in your answer. All right, so this was 2 to the 9th power. This is -5 to the 7th power. Let's look at it with letters. Same thing. X to the 3rd power times x to the 7th power. We are going to add those together. 3 plus 7 equals 10. So I have x to the 10th power. All right, let's take a look at our next one. So here we have powers of powers. So 3 to the 4th to the 3rd power. Again, for this one, just to kind of illustrate it for you, I'm going to write it all out so you can see why we're doing what we're doing. So 3 to the 4th power, so 4 3s times another 4 3s times another 4 3s. Okay, so 4, 8, 12, I have 3 to the 12th power. I don't expect you to write all of that out. I'm just showing you as a way to help you understand why we can multiply that together. So we did 3 to the 4th power times 3. That's where that came from. All right, let's try the next one. W to the 5th power to the 4th power. So we're doing W 5 times 4. And that's going to give me W to the 20th power. I definitely don't want to write out 20 W's if I can avoid it. All right, and then our last part from that key idea, when we have an exponent on the outside of parentheses and more than one base on the inside, we can do distributive property. We can take that power and put it on each part of the base. So I can change that into 2 to the third power x to the 3rd power. And then I can go ahead and simplify that all the way out. That's usually when we do this type of thing, to simplify your answer. So 2 to the 3rd power, I'm going to do over here. 2 times 2 is 4, times 2 is 8. So my fully simplified answer here is going to be 8x to the 3rd power. Okay, let's try this next one. So I have 3xy squared. So I'm going to take that little 2, that exponent, I'm going to put it on each one of my parts of the base there. I'm going to do 3 squared, x squared, y squared, and then I'm going to simplify that. 3 squared is 9, x squared, y squared. All right. Okay, so go ahead and try these. Simplify the expression. So go ahead and pause the video. Try these 9 problems on your own. All right, let's check our answer. So 6 squared times 6 to the 4th power. When we are multiplying with the same base, we can add those exponents. 2 plus 4 is going to give me 6 to the 6th power. All right, negative 1/2 to the 3rd power times negative 1/2 to the 6th power. So I do negative 1/2, and then I add 3 plus 6 to figure out how many I have, and I'm going to have negative 1/2 to the 9th power. All right, z times z squared. Z is like z to the 1st power. So z, and then I'm going to do 1 plus 12. And that is going to give me z to the 13th power. All right, let's take a look at number 4. Here I have a power of a power. That's where we're multiplying. So I'm going to do 4 times 4 to the 4th power times that exponent of 3. My final answer is going to be 4 to the 12th power. All right, y squared to the 4th power. Okay, so we have y, and then we're doing 2 times 4, and that's going to be y to the 8th power. All right, and then I have negative 4 to the 3rd power, and then squared, so negative 4, and then I'm doing 3 times 2. It's going to give me negative 4 to the 6th power. All right, and then for our last ones here, 5y to the 4th power, 5 to the 4th power, y to the 4th power. All right, 5 to the 4th power, we actually calculated that earlier. It's 625. Y to the 4th power. AB to the 5th power, A to the 5th power, B to the 5th power. Okay, 5/10 mn squared. We're going to distribute that. 5/10 squared m squared n squared. 5/10 squared. It's like 5 times 5, 25. But I have 1 2 decimals, so I need 1 2 decimals here. So I have 25 hundredths m squared n squared. All right. So let's look at this one. A gigabyte of computer storage space is 2 to the 30th power bytes. The details of a computer are shown. How many bytes of total storage space does the computer have? Okay, and then here it says to convert from gigabytes to bytes, we need to multiply the number of gigabytes by 2 to the 30th power. So let's take a look over here. We want to know how many bytes of total storage. So we need this information. The total storage is 64 gigabytes, and we want to know how many bytes. So 64 gigabytes. Now our options here have a base of 2. So we're going to go ahead and change 64 into 2 to something. Okay, so let's figure out how many 2's it would take us to get to 64. All right. So I'm just writing some 2's to start. Okay. I know 2 times 2 is 4 times 2 is 8. And then I would need 2 of those. 2 times 2 is 4 times 2 is 8 to get to 64. So I know 64 is the same thing as 2 to the 6th power. Okay, so now I'm going to do 2 to the 6th power times 2 to the 30th power. Now that the bases are the same, we can add the exponent. So we'll have 2 to the 36th power. And then story problems have a label. So it's going to be bytes. This one. All right, last one. How many bytes of free storage space does the computer have? Let's go back a second. Looks like that's 16. So we need to do 16 times 2 to the 30th power. Go ahead, pause the video and try this one on your own. All right, let's check our answers. First thing I need to do is change 16 into 2 to something power. So let's figure out how many 2's that takes. 2 times 2 is 4. Times another 4 would give me 16. So I have 1, 2, 3, 4's. I'm sorry, 1, 2, 3, 4. 4 2's. That gets me to 16. So I have 2 to the 4th power times 2 to the 30th power. And that is going to give me 2 to the 4 plus 30, which would be 2 to the 34th power bytes.